Hi, this is Ed Z from MedCal. I'd like to welcome you back to our latest MedCal video series. In this video, I'll be showing you how to enhance your soldering experience on high thermal demand loads. I'll be introducing you to our newest red handle, which is our high thermal demand handpiece and new cartridge series. Thank you for watching. Welcome back, everybody. This is Ed from MedCal. We promised that we would show you a video about the high thermal demand handpiece. I talked about it in my last couple of videos, and what I'm referring to is the red handpiece that uses special tips with different heaters that allow you to transfer more heat energy or more power from the power supply down to the thermal load. Okay? Now, what I've decided to do is I've decided to show you by comparing apples and bananas. And when I say that, what I'm referring to is both of these cartridges are 5mm cartridges. The main difference is this cartridge is a high thermal demand and it's 700 series. This cartridge is an STTC 817, which is an 800 series cartridge. So what I'm hoping for is, I'm hoping to compare the higher temperature versus the lower temperature, and I'm expecting that the performance at the lower temperature, or with the lower temperature tip, to be better than at the higher temperature. And what that'll be for you guys is, that'll show you the benefit of being able to use more power but lower temperatures, which are going to be safer for your board. So I haven't tried this yet, so let's just see what happens. I'm ready to be embarrassed. Anytime you're working with these tools, you got to remember they're hot. Yesterday I made some jokes in my last video where I talked about not having fingers of steel, and here I will probably prove that. So let's get started. Now, one of the things that's fairly common is just simple wire connections. So what I'm going to do is I'm just going to bring in a 14 gauge wire connection. Now this is a little bit outside of the realm of standard electronics, but I wanted to have loads that you could duplicate, in your own facility. So now what I want to do is I have this is my 817 tip. The easiest way to tell is it is on the silver handle. It is the skin of your shaft. So if I come in here and I start to heat the wires up, even with this 800 degree tip or 800 series tip, you can see the reflow is pretty quick. So now I'm going to leave that on the side since it's hot, and I'm going to bring in the same load, but this time I'm going to go 100 degrees cooler, and I'm going to use my high thermal demand cartridge. And remember, this is operating at a lower temperature, and wow, did that solder quickly. So we reduced the temperature, we reduced the operating temperature of the tip, but we actually increased the performance. You can see, if you look at the solder joints, you've got actually better quality from the high thermal demand. So let's try that again. This is a little different load. This is a lot longer. So let's just try it again with the standard 817. Notice I pre-tin it so I get a good chance at getting a thermal bridge. Pretty good. Didn't get really enough solder on it, but you could see that it reflowed fairly quickly. Now I'm going to try the same thing with the high thermal demand. And remember, the operating temperature is 100 degrees cooler. And you can really see the increase in performance. Same exact solder joint. I'll move these out of the way as they cool off. Here's one that would make my high school electronics, or actually my high school electricity teacher, shudder when he looked at this horrible splice that I did here. But what I'm trying to do is I'm trying to get the solder to wet all the way up to the tip, which is what I'm hoping for. Try that again. Go in the same direction just to make it fair. So it looks to me like we're actually exceeding the performance of the standard tip, and we're going 100 degrees cooler. And these are heavy loads. These are loads you wouldn't normally see in a typical soldering environment. Okay, so one of the common demonstrations you might see at a trade show is the use of the penny as a demonstration for the capacity of your soldering iron. So what I've got here is I've got a couple of pennies, and I'm going to do my best now to zoom in a little better and see what I can do here with the, see if I can solder the two of them together. There we go. So we just formed a little penny bridge there. Now the thing to remember is that's going to stay super hot while we're waiting for it to cool off before we can move it. So I am going to slide that out of the way. And now I'm going to come in with two more. And let's see if there's a difference when I use my high thermal demand. I'm hoping there is. And let's see, with those other two pennies off to the side, I stand a really good chance of burning myself, don't I? Now, look at the difference. Look how much faster that was. Doesn't seem like you'd be doing too much penny soldering at the bench. But when you have a high mass or you have a big heat sink that you need to solder onto your board, wouldn't you rather do it within the 3 to 5 seconds that the IPC recommends? Not have to preheat it. Just be able to go in and solder your board assembly without doing any damage. Nice and fast. So like I said, this is a pretty common demonstration that you'd see at a trade show, because there you've got a bunch of people that are looking for a way to bring you over and amaze you at the thermal performance of their soldering station. But look at this. Look at how this is able to solder this high mass, a mass that you would never encounter on your circuit board. Unless, of course, you work for the US Mint and for some reason you were putting coins back together. So, as you can see, you get higher performance at lower temperatures using the high thermal demand handpiece. Thank you, be safe, and thanks for watching.